What's up, my analysts, and welcome back to the Analyzing PowerShell Payload series, episode 6. And here we're going to shake things up a bit because I'm going to show you how we can use PowerShell to actually be a malware loader. And then we're actually going to get out of CyberChef and we're going to do some basic malware analysis today, guys. But don't worry, I am not a reverse engineer and I barely know anything about malware analysis, but I'm going to show you how you can use some free tools and some straightforward kind of tactics to extract some tactical intel from malware to help speed and add context to your investigation, as well as present the data in such a way that you're going to set your reverse engineers up for success by presenting them with a clear path forward so they can do their jobs easier if you need to get a full malware report afterwards. So without further ado, let's just jump into it. We're going to burn right through the CyberChef piece because we've done this a billion times already. So we take that, get our base 64, and now we have something that looks a bit different, right? So we have this variable, and then we're reading a whole bunch of what looks to be base 64 data in there, and it just remains. It's all base 64, and we get to the bottom here. Okay, we get there and we see our keyword from base 64 string, and that's that variable name. So as we thought, that's base 64 data, converting it, decompressing it, converting it to a byte array, which we understand that already. And then we get to our new keyword, which is reflection.assembly load. And what this means is that this is using PowerShell to load some .NET assemblies and execute them. We don't need to get into the nitty-gritty details of what that means. All you need to know is that if I see that, that means there's some .NET code running, and I'm going to have to inspect that .NET. And the next piece here is this : this is calling a function install1. So when you see something presented to you like that, that means we're going to be looking, there's some function within the .NET assembly called install1. So we know we got .NET, we can key off of that, and we know that we're looking for a function called install1. So, and it looks like they have everything kind of put on one line here. So all we can do here is copy, and we can paste this. I'll show you. Ew, that's kind of gross, right? Because it's all one line. It doesn't look great. So let's go back into CyberChef and just do a find replace. We're going to replace all the semicolons, which is a command terminator, and replace that with /n, which just makes new line. All right. Now, this is very simple, but all we're going to do here, can you guys, hopefully you guys can see that. I'll make it a little bit bigger. Is we're going to comment this out because we don't want to run it, obviously. We don't want to load it, but we know that we have all of this stuff in a byte array. And what we can do is use the function write all bytes. Let's see, hopefully I didn't have my, yeah, I have my practice one in there. Because believe it or not, guys, this is live. One take, I do this straight on through. We don't mix and match stuff together. We're cruising through it. And I think that shows just how easy this is. I'm just saying. And we're going to write this command. So this is going to use the write all bytes. We're going to write this file off to stage1.bin. And there we have our byte array. So we'll save this so we can run it. And boom. And now we have that. And it should be in my episode 6 directory. We see stage1.bin there. Okay. So because it's .NET, we know that. We can confirm that with a tool called Kappa. I'll show you that real quick. So Kappa is a tool that's available. It basically analyzes binaries and says what this binary is capable of doing, because we can use those hints to find out where we're going to drive this investigation. And this is going to try to take a look at it. Word of caution about Kappa, though, that I just messed up there, is that you have to run it as administrator or it won't do it. So I'll show you. Page1.bin. And it's basically going to say, I can't look at .NET stuff. You got to use another tool to take a look at this. And the other tool that we're going to look at, see, .NET module. So the other tool we're going to look at is called DNSpy. And I'll put links to everything as per usual. These are all free tools in the description. And we're just going to open that stage1.bin file. And like I said, you don't need to know anything about .NET. Don't need to know anything about assembly. Don't need to know any of that. What we do know is .NET, and then I said before we need to look, and we're going to try to find a function called install1. So we can simply just go up to edit, search assembly to install1, There it is. Right click, say go to reference, and boom, what do we see here? Hopefully by now you just recognize base 64 data. But if we keep on scrolling down, we'll confirm that because it says reading that into a variable, and then we have our keyword from base 64 string, right? Just like in PowerShell, there's such a crossover. I mean, PowerShell is just the .NET interpreter at the end of the day. So we have all this, and we know that. So, and you can see here in dnspy, it said it'll concatenate if it's too long, but that's no big deal. You just right click on it and you go to edit IL instruction, and you'll get the whole thing in there that you can grab. So we're just going to Control A to copy it, or just select it, copy it, and we will paste that. Because it's base 64 data, we'll put it into CyberChef. And we'll do from base 64 data. Okay, now, next set of keywords here in CyberChef. We see this right here. It says this program must be run under Windows 32. So that's an indicator this is actually an executable. And then we can confirm that when we see the first two things here is MZ. That means that this is the type of portable executable. Okay, cool. There's nothing else we have to do there. But that means that this is a portable executable that is packed within another executable, which was packed within PowerShell. There's a lot. So we'll save this off. Stage2.bin, we'll call it. We'll see if Firefox yells at me. Nope, it doesn't. It says no malware detected. Okay, so we will cut this off and paste it. And we're going to run kappa again. And we're going to say, okay, kappa stage2.bin and see what we got. Now, kappa does take a few minutes to load. So while it's doing this, I'm going to load up another free tool called PE Studio. And PE Studio has a professional edition, but I'm going to show you just the free one. And we're going to load this up because it also needs to run some analysis. But we see one of the cool things about it is that it automatically does a virus total on the hash. And we can see, oh, obviously we're on the right path, guys, because this is already hitting on some things. So we'll go back. You can see that it's running. And just like we did before with CyberChef, I'm going to tell you about some keywords that you want to look out for. So we can see that it has the ability to do some execution, discovery, and defense evasion. Another thing I love about Kappa is that it tags stuff to MITRE. And we go down to the capabilities. Now, there's certain things that I want you to keep an eye out for. So the first one is contains an embedded PE file, contains a resource section. Now, a resource within a DLL, which is what this is you can add other executables to the DLL and you put them in the resource section. So this, with these two together, you can pretty much assume that within the resource section of this DLL, there is another portable executable file. And the other thing in here we see is the encode data using XOR. So there's some sort of obfuscation happening in there. Okay, so we see this here. Everything's kind of lighting up on VirusTotal, but let's open it up on VirusTotal just because I want to show you something else, indicator keywords you can kind of key in on in there as well. So we'll go ahead and search this. And here we go. We see, obviously, we know all the signature hits. Now we see here that portable executable DLL. So if you can't figure out how to tell what kind of file it is, people that do VirusTotal do a fantastic job of kind of tagging stuff. And then again, we see XOR crypt. So we know this is a DLL, it's a portable executable, and there's some sort of obfuscation associated with it. Okay, so we'll clear this out. We don't need that again. We'll go back into here. So how do you find out where the portable executable is, right? So there's two ways. Obviously, in PE Studio, you can see that resources are here, and it's already tagged this one, help, as being a language is written in Russian, and PE is going to flag that. And it's also pretty large. So let's check now. Now there's a way we can confirm this using Kappa, which I think is a very cool feature. Is we're going to do --v for our -vv for very verbose, and we're going to say executable. And basically, all we're doing is saying only run the rules that are associated with the executables against this, because that's all we really care about at this point. And what I like about with the very verbose tag is it is actually going to tell you where in the executable the associated capabilities reside. So we can use that to kind of confirm what it's saying. So we have, we go up into our contains an embedded PE file, and then we see this right here, this number one. We don't need to worry about what this actually means, but you see 15CF4. We go over to PE Studio. What do we see is it is at location 15CF4. So we got a match here. We know that this is what this is. So we can right click on that, go to instance and dump. And we're basically just going to dump the raw data. We will call it help rc data.dump. And it should be in our episode 6. Okay, so before, if you remember, we were able to load that data to find out, to confirm that it's a portable executable in CyberChef. But you can also do that with Kappa as well. So we already have it in there. So we're going to run it on there and find out what kind of capabilities it has. Oh, that's weird, right? It says the input file does not appear to be a PE or ELF file. So it's saying this isn't an executable, dude. Like, I don't know what you're trying to pull, but this isn't it. But we know based on how resources work that it is tagged as a portable executable, and you can put it in the resource section of the DLL, so that doesn't jive. But remember, there is some obfuscation and there's an XOR on that. So maybe this data is XORed. So what we're going to do now is we can do something cool against CyberChef to the rescue. We're going to just drag this up here, and I'm going to show you a cool function in there. So we're going to say XOR brute force. And what this will do is actually go through all 256 possibilities of the different keys and try to find out which one it is. Now, I recommend when you're doing kind of executable analysis, change this length to like 200. Now, if you remember, on the first embedded portable executable in CyberChef, we were able to immediately recognize it as an executable by seeing it says this program could not run in DOS or Windows 32. And then the first the first byte in there, the first where was MZ, which is denoting it as the portable executable type. So what we can do is just search for this program cannot be run in DOS. And we have our first 2 bits there that are MZ. So we confirm that 7B is the key that we need to use. Cool. So we can do our XOR just like did before. We're going to disable that, and we're going to do 7B. And now we have our stage 3 binary, right? And I think I forgot to delete it from my practice run. So we'll get rid of that. And we're going to save this off, call it stage 3.bin. And we'll see if, oh, I knew it. So that's a good sign. Firefox is saying you're downloading malware, bro. Knock it off. I say I will allow it, because we're going to do some more analysis on this. Okay. So, all right, exit here. And we'll load it up again in PE Studio. See what we got in there. Let it run through its checks. And the next thing we're going to do here is we're also going to do Kappa on it. So we're going to do Kappa on stage 3.bin. And there's going to be some more keywords we got to key in off here. Okay, so it's starting to populate in PE Studio. We see that there's a bunch of different hits again. So again, we're on the right track. Now this would be our 3rd or 4th embedded executable within this thing. So we're peeling back the layers and say, okay, so the PowerShell is the loader. And then we get to the next thing, and then it extracts some .NET code, which then extracts a DLL, which then has a obfuscated DLL inside of that. So we're peeling back the layers to say, okay, so now I got like 3 different hashes I can search for across the enterprise to see has this shown up anywhere, or proof of successful execution would be like, I see the first hash, but I don't see the second hash. What kind of context we can see? Maybe AV caught it, so we'll check those logs, right? So we can see if this thing actually runs, it's going to unpack 3 different DLLs, each one of them with a unique hash that we can check. See, this is going again. This is already being tagged as GootKit. If you're not familiar with what that is, you Google it, read all about it. It's great. Here's some more indicators that we have here. There's a lot of string values, 3,983 of them. We can see some things being loaded in here, and we'll see that those tie back into Kappa. This is done with some capabilities that it has. Now, keywords here of like when you've met your match, when it's time to pump the brakes there and call in an expert, is when you start seeing these, which is like anti-behavioral analysis, anti-static analysis, anything that's dealing with like trying to stop or reverse engineer from being able to quickly get the intel out of there. You're probably done from a high level first pass kind of triage. And at this point, you're going to have to start getting a debugger involved. But there is another keyword in here, which is good and would be good information for your reverse engineer. Like I said before, to set them up for success and also point them in the right direction to quickly get what you really want for, which is communication, right? So it has the capability to connect to a server, create and process requests, which means somewhere in there within all the obfuscated data is going to be an IP address or a domain, more than likely, right? So what we can do with Kappa now is say, okay, cool. Well, I want to do this for my, I want to make life easy on my reverse engineer and say, okay, just run the communications and do dash very verbose. And what this is going to do, we could output this to a file to pass it along to the REs and say, here are all the locations in the binary that are associated with communications. Can you process this? See if you can pull an IP address out as quickly as possible so I can go ahead and retrospectively search across, you know, the enterprise for like network connections for that. So now you know how to do some very high level malware analysis without having to know anything about coding or anything fancy. But doing this, we're using free tools, we were able to take a PowerShell command and from that acquire 3 different hashes of executables that are associated with this loader, which would help you quickly kind of triage more systems within an environment. So I hope you like this. In the next episode, we're actually going to look at another C2 framework. We're going to be looking at Covenant, and we're going to look how to process and extract the tactical information from their launchers.